All right, I think everything's set up. If folks can let me know if they can see and hear me okay. Just getting going. Just came out of a department meeting, sort of a last minute rallied department meeting. So I had to run down the hall to make it to this, but here we are. Looks like the live chat is up and going. Looks like we have some of our amazing moderators here, Susan and Amanda Joe. Awesome. I think Lisa might be joining us in a bit, so thanks to them for getting on here. Let me know if you guys can see and hear me okay. That'd be great. Looks like J. Scott McLean from Kingsgate, Washington says we're 5 by 5, so that's good news. Need a quick little sip of water before we get going. Alrighty. Okay. Yeah, so you can see the outline. We'll get going here in about 10 minutes or so, just greeting people as they come in. And we'll say hi to some folks. Carola from Lake Constance, Austria. I was just in your country a week ago. Beautiful. We were in Vienna, went to the Wachau Valley. Amazing. Pieter from Sweden. Andrew from Texas. Stephen from London. Tim from Ontario, Canada. Giles from the Netherlands. There's my friend Elaine from Tucson. Dan, how are you? Pascal from Luxembourg. Rachel from Central Texas, Pam Hawkins from Stevensville, Montana, Diane Gerlach from Wisconsin, Jamie from Inverness, Scotland, Hans Heinrich from Denmark. Greetings, everyone. Thanks for making time today to join me. Real Truck from Baton Rouge, Jesse Maria, thank you. I'm happy to be back with you guys. Sandrine is here from France. Marco from Sweden has already started on his Encyclopedia of Volcanoes. No small task, my friend. You're probably further ahead than I am on dealing with this monstrosity of a book. Great reference, though. I wish I could just find a week to just hunker down with that thing. Garrett from Wiesbaden, Germany. Jocelyn from Red Bank, New Jersey. Jack from Santa Rosa. Oh, someone from, what did I see there? Was that I thought I saw it kind of skip down. The chat fills in and then it pushes it all down, so I miss folks. Living 4 from Namibia, that's great. Jane from Longmeadow, Massachusetts. Rocket Boy 3000 from London, UK. Mary from Pensacola, greetings. Mikhail from Ironbridge, Shropshire, England. UK. Safi 19 from Scotland. I know it's a little bit later over there, so thanks for joining me this evening. Jim from Leonora, Washington. Frank from Torrance, California, where it's just after lunchtime. Laura from Perugia, Italy. Moria from Netherlands. Joe from Jacksonville. Ali Hujo 12 from England, Manchester. Kide from Stockholm. Susan from Minnesota. Jean from Fairbanks. I don't know why I read these. I mean, you guys can see them as well as I can, but it's probably fun to get the little verbal shout out, I suppose. We got to fill this little bit of time up with something before we get officially started. Michael Harmon from Bethany, Oklahoma. Leanne, Australia. Vera from the UK. Charlotte Rose from the Peak District, UK. Peter from California. Jay Moore from Astoria. Betty from Atlanta. Richard from Vienna. Awesome. Loved Vienna. Loved Prague too. Prague was really amazing. Beach and predator fishing antics from Lincoln, UK. Jim Strickland from Arkansas. George from Albuquerque. Marlies from Germany. Jenny from Sweden. Tall Paul from Calgary. Queen of the Rodeo in Finland. Oh, it's almost 11 o'clock in Finland. Pulling a late night one there. Thanks for joining us. Susie Sue from Ohio. Cactus Wren from New Mexico. Yeah, and if you're somewhere where it's late and this isn't going to work from you, you can always catch the recording. A little bit different experience, but sleep's important, team, so don't overlook that. Ken Crowley from Ireland, Iraq from Reno, Uroj from Helsinki, Steve from Texas, John Cameron from Klamath, California, Jerry from the Netherlands, Pat from Ireland, Mike from Boulder, Kenneth from the UK, Sharon Dennis from Arizona, Frey Enevold from Denmark. If I mess up your name, I apologize. Susan from Ohio, Carl from Sweden. Yeah, I know about Val Troll's channel. He's got some good stuff. Um, Draftsman from Lyle, Washington. Catherine from Sheffield, UK. Matt Bax from Atlanta. Darren in Kansas. Rebecca, Oak Island, North Carolina. And the live streams are a little different experience, right? I know some of you like the quick hitting, brief update without all this chit-chatty stuff, and that's fine. I'll go in after we're done and add the little chapter headings so that you can skip ahead if you want to, if you're watching on the recording. But I know a lot of people, myself included, enjoy the live stream format as a way to interact and be together. It's a nice community building thing, but it's not for everyone, and it does take a little more time. Patsy from Davison, Michigan. Mark from the couch in South Carolina, I guess. John from Lincoln in England. AJ from Rock River, Wyoming. Stephanie out in Oregon. Oh, it just skipped down again, so now I got to figure out where I was. Kim from Boise. I think I missed a few here. Ari from Reykjavik. David in Meridian, Idaho, just up the road here. Kylie in Melbourne. Gail in Helsinki. John from Klamath, California. I missed a few folks here. Let's just get John from Sicker Point, Scotland. I've been there. That's a really cool spot. One of the holy Mecca pilgrimage sites for geologists. Kim from Boise. Anne from the mountains of North Carolina. Alexandra from Hamburg, Germany. Coley from Norway. DJ Nedenbane from the Isle of Skye. Carol from West Sussex. Brendan, South Africa, greetings. Joanne from Chesapeake, thanks for the hat, Joanne, still wearing that. Asta from Iceland, hello. Lava therapy time in Iceland, indeed, Laura. Paula from Wales, Margaret loves this stuff, thanks, Margaret. Kim from Rochester, Martin from Latvia, amazing. Robert from Central Texas, on vacation in the Ozark Mountains. Yeah, and if you have questions, we've got some directions there on the live chat as to how you can submit those. That helps the moderators keep things nice and tidy, helps us organize and aggregate those questions so that they can get those to me at the end. Like a lot of these live streams, I will try to get to as many as I can, but undoubtedly we'll end up with more questions than I have time for. So I do apologize for that, but we'll try to get to as many as we can. Steve from Nashville. Steven from Inside My Head. Ooh, hopefully that's not too scary of a place. Vincent says aloha. He might be in Hawaii. Jeannie Curtis from New Zealand. I don't know what time it is there, but it's probably tomorrow, right? It's probably Wednesday. Tim Pointing from Newmarket, Ontario. John's watching while he's working from upstate New York. Clinton, Iowa. Amber Woods. Kirk in Sweden. Super from Norway. Raji from the UK. Yeah, lots of European folks here. We're probably missing some of our US friends because it's afternoon, middle of the day, people working, running errands, whatnot. That's okay. I'll try to, once we get to summertime and I'm off my teaching schedule, I'll try to vary some of the times of these live streams so that we can catch people from around the world at better times for them. Mike from Washington State. P. Neild from Melbourne. Tim from Dover, Delaware. Oh, it just jumped down again, so I missed a few. Apologize if I miss you. Air Rock from SF Peninsula. Is that San Francisco? I guess. Kirk in Sweden. Uppsala och Sweden, Bjorn. I don't even know. I guess. Yeah, that's pretty cool. Beth from New York City. We were just there as well. First time in New York City. Aussie Yarny from Australia. Nikki from Argentina. Hola. It's morning in Queenstown, New Zealand, 9 a.m. Okay, so it's not a crazy time of the day for folks down under. Jason from Mariana, Florida. Foxford. And then, yeah, it just kind of goes on and on. So Good stuff. We'll get started here in about a minute and a half, folks. But thanks again for jumping on and joining us. We'll start here at the top of the hour with a very special announcement, and then we'll proceed. You can see the outline of the program for today, and we'll have to keep this thing. I have a yoga class to get to with my wife that will mean that we can't prolong this more than 2 hours. So we'll nip it in the bud at 2 hours at the most. So maybe we'll get done a little earlier. So hopefully that works for everyone. Aston from Iceland, greetings. Thanks for the things you've been sending me. Bill Ward from the Hayward Fault. Gordon from Manchester. Croatia, says Andrea, it's 10 o'clock there. Another place I'd like to get to. Lowell from Dallas. Glenn from Langley. It's just so cool. Like I don't know if I'll ever get over just how neat it is that we're able to do this, right? This is the good part of technology, is that this nerdy geologist in his office in Idaho can reach out and connect with so many folks that are interested in learning like I am, and in things happening in other parts of the world. It's just awesome. It always just kind of gives me chills when I think about it. So excellent. Okay, well, thanks so much, friends. It is the top of the hour here in Idaho. It's 2 p.m. Mountain Daylight Time. We're on Daylight Time now. Welcome. I am Geology Professor Shawn Willsey. Thanks for joining me for this live stream broadcast for Tuesday, April 2nd. We have quite a few things packed here in our time together, and I'm excited to get back to this format during my trip to Europe. I definitely missed the live stream format. It's a great way to engage with you all, and I really enjoy it. So I'm going to try to do these, once every 1 to 2 weeks moving forward as time and schedule allow. But I do feel like the live streams are a great way to interact with people. It's a different vibe in a different format than me just recording a video, slapping it up onto YouTube, and then walking away. This is a great way for us to interact a little bit more, so I appreciate it. But our big announcement to start with is that we have our moderators on the live chat as always, but today is Amanda Jo's 2nd anniversary to her husband. So I want to wish her and her husband a very happy anniversary. I'm excited to meet her in person in May when I come out to Iceland, and just want to say happy anniversary to Amanda, Jo, and Omar. So there you go. Big announcement, probably more important than anything else we're going to do here. So, okay, so here's an overview of what I have planned for today. I've got a few announcements we'll make about things I'm doing, the channel in general. I'll do a brief report of and a few pictures of my trip to Europe over the last week and a half or so. What was our spring break? I don't want to bore you too much with a long slideshow. As I'm looking through my photos, I'm like, I don't even remember what building we're in here or what city we were in. It's a bit of a blur and a whirlwind, but it was a great trip. And then we'll get into our update on Iceland, sort of the regular updates that I often do. And from there, I want to start looking at another volcano in Iceland that's been a little bit in the news lately, and that's Askja. So this is a central volcano, a very different type of volcano than what we've been dealing with in the Reykjanes Peninsula. And I want to start with just some basic information about this volcano. And please know this is not me telling you or lecturing to you. I didn't know much about this volcano at all until the last few days when I've been reading some articles, learning myself. And so I want to share with you what I've learned. If I'm wrong, someone can correct me. And just as part of the learning process, it's a great way to reinforce one's learning, is to try to explain it and to teach to another person. So we'll do a little bit of time on that, and then we'll wrap up with the question and answer from the viewers, and we'll get to as many of those questions as we can, and we'll just see how it goes from there. But I probably won't be watching the live chat a lot because I'm kind of running the little dog and pony show here. But for those of you that are over on the live chat, you can follow the prompts of our moderators there in terms of putting in questions and staying on topic, what the rules are there. They're good at kind of keeping everyone moving in the same direction, which is very helpful. For those that are offering support and donations on the live chat. I super appreciate it, and I will make sure that we share that with our moderators as well, because they do a lot of the great work here also. So, okay, let's get right to it then. Since we're done with the little intro thing, let's get into some announcements. So right off the bat, I do have, this is obviously very short notice, but if anyone is in the area or is wondering, I still have some space for some of the field trips that are happening next week, April 12th and 13th, which is Friday, Saturday. These are local trips around Twin Falls, Idaho. They're the same. It's the same field trip I ran last October with about 20 to 25 people. But I do still have some space there. So if you are available and interested, just shoot me an email and I can send you the information and get you signed up and ready to go. I will be putting together some other field trips later this year, but I'm going to wait till probably June or so until I start putting those out. I've got the Iceland trip in May. There's the field trip in June at Craters of the Moon and some of the other places in southern Idaho. Those ones are all filled up. But I will put some more on the calendar. So just look for those moving forward. So that's just sort of FYI. Other things in the hopper that are coming your way sometime soon, although I haven't firmed up a date with Geologist just yet, but some of you might know this person here, the content creator for Just Icelandic. He does great work with providing just insights into Iceland history. He does great footage with his videos and drones, and he's a native Icelander, so that's helpful as well. He has I think a lot of people have mentioned they enjoy just hearing him talk, like the way he speaks English with his Icelandic accent is just, and I enjoy it too. I'm like, wow, I could listen to him narrate a book. But he's agreed to do something with me, and so he and I will get together with some emails soon and firm up a date where we can just chat. I don't know if interview is the right label for these things I'm doing with these other folks, but it's basically a discussion. I want to learn more about what they do. I want to hear their perspective and learn from them, and that's where it all happens, right? That's the way we're designed to work together. So look for that. And then another one I've got in the hopper is Greg Stock. So he is, I believe it's the only national park in America that has their own park geologist. And so he is Yosemite's first and only park geologist. I met Greg, maybe a decade ago. We have some common interests. We're both rock climbers. You can see some pictures of him up here doing research. He's done a lot of work on rockfall in the Yosemite Valley. He was kind enough in 2015. I brought a group of students out to Yosemite, and he took some time to show us around the valley at some of the rockfall hazards and some of the deposits. So he's away on a vacation right now with his family, but he's agreed to circle back and do some sort of interview discussion thing with me later in the month. So I'll be doing something with Greg Stock going forward, and he's incredible. I think you guys will really enjoy what I want to do with him. As you in setting up these interviews with these people, I have to think about like, okay, what's the best topic, or do we want it to be more free form? I think folks would be really interested to hear a little bit about him and his background, but then also his work on rockfall in Yosemite Valley, because when I took students out and we met with him, I learned a lot, and there were things I just did not know or maybe underappreciated about the role of rockfall in an environment like the Yosemite Valley with those big sweeping cliffs of granite. And so we'll hear from him. I think that's the angle I'm going to pursue with him. So hopefully that will be good. So there's another little bit of an announcement there. We've done their interview with Amanda Joe. We did one with Ariana Soldati, who is a volcanologist at North Carolina State. I thought both of those went well. I did the chat with Nick Zentner. That was great. We'll probably do something else with him in the future as well. But right now I've got a short list of people I want to bring into this channel and this community and have them teach us and learn from them. So these are some folks I've got in the short term to look forward to. Okay, and then I was in the news in a couple fun little things recently that some of you might be interested in. And so I've got video links for these on the under the video description. So I didn't even know this was, had never even actually heard of this YouTube channel, but there's a very popular science education YouTube channel called SciShow, and they do great work. And they reached out to me maybe a month ago and wanted to use a little short interview with me as building a video about the Iceland volcanoes, and in particular, this video is called, well, why volcanologists hate the dark, but it talks about some unique methods of observational data and data acquisition that we use in volcanology, just this spectroscopy and some different things. It's not too sciencey. I think it sets the right tone. It's a good, it's not too heady at all. So you might watch that. I think the whole thing's maybe 8 or 9 minutes, and there's some clips of me in there. And then I didn't even know about this until a viewer let me know that the CBC News, which is a news agency in Canada, used a few seconds, maybe it's 5 seconds of fame or something. They have a nice little program called why Iceland's lava is so hard to stop. And they did a nice job with that. And there's a little small clip of me from I think this is 2014 in Kilauea, where I'm sampling some of the lava there. So they've got a little snippet of that. But it's a well done video, and those are all in the video description. So just some fun stuff there. Just want to share with you as a community. And then another big thing that happened over the last couple weeks, I guess sort of a landmark achievement, is that the channel here reached 100,000 subscribers, which is awesome. And had you told me that I would get to this point even a year ago, I would have said you're crazy, because I literally remember, and some of you have been with me for a couple of years here, where it was I wasn't trying to grow the channel. I was just doing what felt good, and it was growing organically, very slowly on its own. And probably like in the fall, like September, like literally 6 months ago, when I was at like 20,000 subscribers, I thought, this is amazing. There's 20,000 people that actually are interested in my field videos and what I have to say and just learning geology. And I thought that I was humbled just by that. So the fact that we were able to, oh, here's the comedic moment. The light just went out. Okay, it's back on. 100,000 subscribers, but he can't keep the lights on. But the fact that we've been able to get to this point is amazing. Obviously, the events in Iceland have really helped to propel it forward. So this is not about me. This is about us as a community. So whatever you've done to help share geology education with people in your world, in your community, this is about you just as much as about me. And really, this is just a number. It's not, it's exciting, it's great, but the real joy I get in doing this is in comments like these. So, here's Mindy's dad. I don't know who this person is, but left a comment using my classroom videos on rocks and minerals for his daughter's homeschool science work, and he's learning with her. Like, that's awesome. Like, that's why I do this. That's the warm fuzzies that I get from peeling away time from my day and spending time with you good folks. Or Jackie in Ohio, little comments like these telling me that I'm doing it right, that I'm somehow connecting with her. Whatever I'm doing to convey geology information, it's working for her. Or Christine in the UK, a 74-year-old British viewer, reviving her interest in geology. This is why I do it. And so I just wanted to share these, not as a ego stroke or a pat on my back, but just to let you know that I appreciate all of you, and that this is the fuel that keeps me going, are these sorts of comments that let me know that that it's making a difference, right? I think that's what we all want in this life, is to just know that the things we're doing professionally or privately, that it's helping people and it's making a difference. And so the number, I think, speaks to that, but more importantly, the comments speak to that too. So anyway, that's enough with that. But we reached this threshold. Apparently there's some silver play button plaque that's coming in the mail. I think it'll be here on Thursday. So when I get that, and at the next live stream event, I'll be sure to show that to you, because a lot of people have said to show the little plaque. But really, that plaque and this number is more a testament to all of us being interested, being invested, and having a good, positive, engaging, and educational learning community. So, cheers to all of us. Okay, just a couple quick picks from our trip to Europe. So, my wife found a good deal, package deal, I guess last May, where it was like 3 days in Vienna, 3 days in Prague, airfare, hotels included. And so we jumped on it along with two other couples that are friends of ours. And I didn't know much about it. I said, hey, I'm not a city person. You plan the trip. I'll go along. I will be fully invested and I will love every minute of what we're doing. And it was fun. I mean, I'm still not a big city person. This was a day we actually were able to get outside of Vienna into the Wachau Valley and go up to this old castle where, like, I don't know all the stories, like King Richard the First was held in prison here. And it just gives you perspective, right? As someone born and raised in America, going to these other places where you can see this much longer human history is always very valuable. So there's Dürnstein Castle. A viewer named Janet, who's shown here in the lower left, reached out to me by email and said, hey, if you're coming to Vienna, I'd love to meet you. There's a great little classic coffee house we can meet at for breakfast. So this is a fun little picture of me and my wife and our 4 friends meeting with Janet. And it was a lovely little breakfast, and we learned a lot about her and her life and more about Vienna and the culture. She sort of moved there from the US when she was about 18 or 19. So thank you, Janet, for that wonderful breakfast you treated us to and for just being a great host. This is a road cut I did. So we did a bike ride through the Wachau Valley. And so I did do a couple of videos on my trip. And this is the next random road cut. Probably hard to tell much about what's going on there from this photo, but I'll show you some close-ups later when I get that one posted and uploaded. We went to Prague after 3 days in Vienna and was just blown away by the cool old Gothic architecture. I think in this cathedral I saw more stained glass than I've ever seen in my life. And there was a lot to look at and take in the cathedral here in Prague. But of course, as a geologist, my eye was often drawn to other things. And so I spent a lot of time looking at the rock that was used in building this beautiful building at the floors. There were some wonderful fossils in some of the stone that was used here. You can see these, I don't know, nautiloids, or these might be belemnoids, I'm not sure, but these cephalopods, these related to the modern squids. Some of these fossils here, so you can see these are crinoid segments here in this limestone. Here's another probably nautiloid fossil in some rock here. And so I was just really drawn to all the cool rock as we walked around, not just this particular location, but also around the city as well. So, and I did do a video in Vienna of some of the rock on some of the different buildings in downtown Vienna, because there was quite a diversity. I would guess a lot of the older stuff was locally quarried. Maybe some of the newer rock on the more modern buildings was from further away, but I did do a video on that you can look forward to. And then another video I did in Croatia, we did spend one day outside of Prague, and we went to a place I wanted to go to called Prachov Rocks. And this is this beautiful kind of labyrinth of these fins and spires of gray, I think it's 50 million year old sandstone. So I did a video on these as well that you guys can look forward to over the next few weeks. It's also a rock climbing destination. I didn't bring my climbing gear, but I would love to go back and climb here. It was just pretty incredible. You can see some of the crazy textures on the wall with this cavernous weathering. And I don't know exactly what causes that here. There could be a little bit of calcite in the rocks themselves. I didn't have my normal test kit with me. Not quite sure why it weathers this way, but pretty spectacular nonetheless. And so you can look forward to that video coming up soon. And then we ended our trip with a few days in New York. I'd never been. My wife had been once before. The other two couples had not been either. And maybe the highlight for me, because by this point I was kind of like done with big cities and crowds. I was just ready for expanse and nature, and I found that to some degree in Central Park. So rode a rental bike through Central Park, and did a video on the rocks that are exposed here. And so there's some really nice geology in Central Park, history of glaciers, metamorphic rocks as well. And so that's some things you can look forward to moving forward. I've got a few videos coming at you from that angle. So, okay, that's that little section. Let's now turn to things happening in Iceland, which I know many of you are have been paying attention to over the past, well, several months now, I guess. So here's a live cam view. It's still erupting. Our eruption that began on March 16th is still persisting. The activity has slowed from what it was those first few days, but it seems to be fairly stable over the last, I guess I'd say 3 to 4 days. Doesn't seem to be showing any signs of slowing or ending anytime soon, but that's somewhat up for debate. I do want to show you a few other things related to this. So there's the live view. That's happening right now as we speak, about 8:20 p.m. there in Iceland. Here what I have for you is a little bit different view. Let's get this. There we go. And what I did is I went back in time. So this is last night, or I guess earlier this morning. Yeah, you can see like kind of the dawn breaking there over the webcam. But what I want you to look at here is primarily this bottom left webcam, where you can see the vent. This is the northernmost spatter cone that's producing the lion's share of all the lava that's being erupted. And then you can see the lava channel that flows out of it to the south. But one of the things that has been happening over the last few days, maybe longer than that you can sometimes see on the webcams is as these lava channels get established and as they thermally erode their levees, you can sometimes get breakouts. And it could be also a lava supply, excuse me, change where the lava actually breaks out of the confined channel and starts flowing in another direction. So I actually paused this right where you might be able to see one of these happening. And I have this sped up, so it's going to be twice the speed it really took place, but I think that'll allow you to see one of these breakouts. So kind of watch this bright spot right about here on the webcam as I push play, and you'll see one of these breakouts of lava start flowing more or less towards your view there. So there it's erupting, but you'll actually see lava breaks out of the channels. Usually the channel walls, what we call the levees, are built up. Oh no, it stopped. Oh, that sucks. I thought I had that all prepped and ready to go. That's a bummer. I did that this morning, but what I'm thinking now is it only lets you go back so far. Oh yeah, that kind of sucks. So I don't think I can go back far enough to see it. Well, that's okay. Well, if you watch it at night, it'll be easier to see than during the daytime. Sorry, team. That was not planned. Yeah, so now it just wants to... I think it only goes back so many hours from the live view. And see, now I can only take it back to, you can see it's brighter there, and I was back further than that. So anyway, what it would have shown there, epic fail, sorry, is lava breaking out of one of these channels and flowing towards you at a fairly constant rate. The lava flows aren't really moving into dangerous ground, though. They're not progressing far away from the main channel. Usually they'll just kind of break out, carry some of the flow with them into some little low area there. So yeah, and if you watch some of the other drone live streams and other things, you can probably see that as well. But these breakouts can be important because it can actually change the path of the flow field. What I have here, and this was sent to me from a viewer, Bruce Garner, is this is one of the webcams from, I guess this would be the 31st, that was Sunday, and it's sped up, so it's a time lapse. But this will actually allow you to see how these spatter cones build up, but then also can be thermally eroded and collapse. So there's this constant battle between spatter, lava being thrown out of the vent, propelled upward by the gases, landing around the vent, and because it's still hot, it welds together and forms this material we call agglutinate, and that agglutinate forms the actual cone, and that builds up over time. So it gets higher and higher, and as long as the lava can be propelled up and over the rim, you can conceivably grow your spatter cone taller and taller. Now, at some point, you reach a finite point of equilibrium where you only have so much upward propulsion from those expanding gases in the lava to propel the lava upward. So if you can only throw lava up 100 meters, then your cone's not going to be much taller than that. And at the same time, what's happening is that lava kind of is just in that pit convecting. It's very hot. It's thermally eroding the base of those slopes, and so you'll see sometimes collapses. So let me just let this play here. This is a good minute or so video, and it's easier to see it at night. So if you watch this main cone, especially watch like right here, this profile where the black edge of the cone is contrasted with the incandescent lava. If you watch that closely, either on this left side or on this right side, you'll see it kind of grow up and then eat away at it, like it kind of drops over time. We've got the lava channel, the river kind of flowing out. There was a breakout right there. So a little breakout on time lapse. It kind of came out the left side. As we get towards the day hours, it's a little trickier to see, but this is kind of the idea. This is the dynamic that's happening currently with this spatter cone. Is it building up, but it's also eroding, and it's this constant battle between lava being added to the rim and the flanks, but then inside that pit, because it's oversteepened, those walls inside that spatter cone are vertical or nearly vertical. Sometimes they can get overhanging and then they can collapse. You can watch some of it get eaten away right there on that right side. So it's widened out that channel a little bit there. So Bruce Gardner sent this to me, and thanks for keying me into this. There are big chunks that broke away there. And then this one starts over. So let's go to, he sent me another one. There's actually, this is from Monday, so this is from yesterday. And apparently we've got a little bit of a bridge here. You can see the lava is pouring out into the channel, but it's not connected to the convecting vent. And so there's a little hardened bridge of lava over the top of this channel where it's being fed here, which is pretty cool. But this just helps you understand kind of how these spatter cones can grow over time, a little bit how steep they are. You know, they've got this steep outer flank, but then the inner pit is sometimes vertical or quite steep. And that stuff's just dripping back down, but then it's eroding. You can see lots of little people scurrying around there during the daytime. And then now it starts looking a little better as we go towards night. Yeah, you can see little pieces fall off, pieces getting added to it. There's another breakout there. Lots to watch here. And I can add those as well too, but this is live from Iceland. They do great work. You can probably find these on their website as well. So, okay, so just some fun eye candy things, but a little bit of instruction on spatter cones. We have a new update from the Met Office today. So they went, almost a week or so without much of an update, but there was a new one that came out today, about 12:50 p.m. Land rise or inflation at Svartsengi has not been seen in the last few days. We'll circle back to that when we look at the GPS data. But let's look at their highlights here. The eruption continues. 2 craters are now active. We've looked at that. Recently, there have been wildfires around the lava bed and the moss, and there's a constant danger of that when the weather is dry. According to Amanda Joe, they've got a lot of that controlled now, so those moss fires are not nearly as rampant as they were yesterday and previously. Gas pollution travels to the southwest and later to the west. It will probably be noticed once in a while in Grindavik. And so with constantly changing wind directions, that's going to distribute those gases downwind into different areas. So we have a hazard of gases. The lava rims, the berms, I think that's what they're talking about, have become high in many places. Oh no, that's the actual volcano. Lava rims have become high in many places, and glowing lava can fall from the lava rim. I think they're referring to the spatter cones there. Again, Google Translate, so we're kind of getting what we get here. They talk about the 3rd crater kind of died out on Sunday, Easter, but it was much smaller than the other 2. The land rise or the inflation around Svartsengi, we've been tracking that over the last few months, but that's not been observed. I'll show you that with some of the data here in a little bit. And continuing with the update, which mainly indicates that the magma is less concentrated in the magma chamber under Svartsengi, but rather flows directly out of the vents. So the idea here is it's not being stored. magma body under Svartsengi was our magma storage zone, the sill, the reservoir, but now we have magma from a deeper source that's able to get right up to these erupting vents without spending time in that sort of storage, that transient storage zone. It is possible that a balance has been established in the flow of magma under Svartsengi and out of the craters, but geochemical measurements could confirm this in the near future. So they need to get some more data to confirm if the rate of inflow of magma into the system and the eruption rate coming out of the vents is in balance. Because if those are the same, then we could see this eruption going on, until that rate diminishes or changes somehow. So the lava field is about 6 square kilometers in terms of its areal extent. The volume of lava is about, since the beginning of the eruption on March 16th, about 26 million cubic meters of lava. Average flow of lava from the craters during the eruptive period was about 8 or so cubic meters per second, but is very comparable to the lava flow in the first phase of the 2021 eruption. That eruption went on for 6 months. And then they have the map here, so we'll go to the map. Yeah, I think that's kind of it. They talk a little bit about the wildfires, but that's the essence of that there. So here is the lava flow field map, and you can see the vents here. And so the darker the color, make this a little bit bigger, this is where the lava is thickest. So you can see it's upwards of 16 meters thick. For my American friends, that's well over 40 feet in thickness. And this thicker spot here, that's that quarry that was filled in. So remember, some of that lava spilled over, cascaded into this quarry where they'd been removing some of the rock to build up the berms. And that's why we see such an exceptional thickness there. Otherwise, you can see that the thickest section of the flows is right around the vents. So that's those spatter cones and spatter ramparts right along that zone there. And then as that lava channel carries lava into this region, it continues to thicken and rise and raise the topography. And this is where we have, a little bit of concern. I think it's fairly well, the topography here is important because we have these two hills, Hagafelt and the Shield volcano over here. So the lava is not likely to spill out to the east or west in this zone because it has topographic high regions on either side. But it is possible that if it fills the quarry further, there's some chance it could start propagating and moving to the west towards the road there. We'll kind of have to see how that goes. There's also another chance that as it raises up the ground in here, we could get a breakout or a spillover, and it could flow back down towards the south here and flow along the edge of this other lobe over here. So there we go. Lights back on. So we'll have to see, but that's a nice updated map out of the Met Office showing how things look. On the earthquake front, not a lot to report. The eruption is progressing. The lava is pretty easily moving from a deeper source up to the surface unimpeded, so there's no reason for that lava to need to break rock or produce fractures, and therefore we're not seeing any earthquake activity around the eruption area for the most part. A few scattered earthquakes over near Fagradalsfjall, a few random earthquakes, through this part of the Reykjanes. And then as you get into the interior of Iceland, there's a few earthquakes here and there. Looks like there's a little cluster here underneath Vatnajökull, the big ice cap. And then we'll talk here in a bit about this area here. This is Askja. So this is another volcano in central Iceland. So nothing alarming here, nothing that would seem to indicate that we have magma moving anywhere or some other area erupting. Let's look at the GPS data, which I think is pretty interesting. If we go to the GPS data we've been looking at the most often, the Svartsengi location, which we believe is the one GPS location that's most centrally located over the magma body, more or less. So you can see the rise in elevation, the inflation going into the February 14th eruption. So that eruption emptied some of the magma onto the surface. That caused the ground to drop down, but then it started picking right back up. That eruption only lasted a day or two at the most. And then that culminated with the, yeah, that was the February. Oh, sorry, let me get my dates right. January 14th. February was the 8th. Sorry, February 8th eruption right here. And then inflation resumed, and that led to the March 16th eruption, the one that's currently going on. So if you look at this trend of data here, we can see that there, it looks like it had a slight rise to it, but the last half of this trend of data points here is pretty flatlined, and that's where we're reaching some of the tentative conclusions that the inflow of magma into the system and the outflow of lava out of the system of the vents might be in balance, because we're not seeing any inflation or deflation, that the ground surface here is not moving up or down. So that is one possible interpretation of that data. And if you look at some of the other GPS stations in the area, you see the same trend. Here's the Blue Lagoon, little bit of an uptick, and then the last week or so, it's just flatlined. It's pretty much level there. The Eldvorp, whoops, that's not the one I wanted. Let's go to the Eldvorp one, and similar trend there, like just flatlining. So no inflation. There does not seem to be any inflation that's going on. So we do have, though, the volcanic gases that have been coming out of the vent. Let me clean this up a little bit. Let's take away, well, we'll leave that one in. We can take out the February one. So with the vent up here, depending on which way the winds are going, it's close enough to the Blue Lagoon that they've kept the Blue Lagoon closed. There actually, I think, been a few workers there that have gotten a little sick from the sulfuric gases, and so they're keeping people out of this area with sort of the fluctuating winds. I would imagine some of those gases might occasionally be getting down into Grindavik as well, although it's probably twice as far, so it's much more dissipated. But they have monitors and websites you can look at to see which way these plumes of sulfuric gases, volcanic gases, are moving at any given time. So a couple of pieces of news that also came through that Amanda Jo sent me. So here's Professor Thordarson, and in this article, I won't read all the quotes. It's probably too long for that. But he talks about when we see from the thermal images that the thermal flow is decreasing, it indicates the productivity is being reduced little by little. It only ends in one way, with the eruption stopping. So basically, in this article, he talks about, it might be a few days or a few weeks, but this eruption is going to end. And then he thinks it will, that he says that the good news is this news. I believe that when this is over, the activity in Sunnakur will end. And he doesn't expect another event to happen on this crater series. That's not to say that there can't be an event elsewhere, he says. And again, I mean, this guy's smart. We've talked to him here. I just wonder, what basis would allow him to make that statement? Like, why does it need to end? Why can't this system continue to erupt for more weeks, possibly months? And even if it did end, maybe he's suggesting that because that conduit's established, the magma reservoir has been vacated or emptied, and so when the lava supply from depth runs out, that means this whole series is over. That would be my sort of way of just kind of connecting the dots based on what he says. But then we have another article where this geophysicist, Magnus Tumi Gudmundsson, this one talks more about how there's a balance between the inflow and the lava erupting, and so that it may go on for a period of time. And so let's see if I can find that actual kind of quote there. I think it's down here a little bit further. Yeah, it says not included that the situation lasts for 1 to 2 years. Again, no one's saying anything definitively. I'm not sticking anything on these two gentlemen by any means, but a bit differing opinions, right? And that's okay. That's healthy to have these different opinions. So he talks about, yeah, it could go on much longer, for a month or even a year. It also could continue continuously for a significant period of time. It's not excluded that the process has been going on for the last few months, will last 1 or 2 years, but there's nothing certain about this. Yeah. So, and maybe some Google Translate issues in there as well, as we often see with some of these Icelandic articles. But interesting perspectives, and that's all I wanted to point out here was that we're, I don't think anyone has a definitive answer on exactly how this is going to play out moving forward, but we're definitely in kind of a new realm of this eruption. We had several in December, January, and February that somewhat behaved similarly, but this one is a different one. This one may go on for some time. We'll just have to see. Okay, so I think that's all I've got for that part of Iceland. And what I want to do before we get to the question and answer section is, one, take a quick drink. And then two, spend some time presenting and learning with you about this other volcano. So you might remember that I think on one of my last few updates, there was some earthquake activity in another part of Iceland that people were starting to pay attention to, and that is this volcano up here called Askja. So it sits north of the big ice cap, the Vatnajökull Glacier, and it's kind of in there's not a lot of people out here. In fact, this volcano, until it had a substantial eruption in 1875, which I'll talk about, is kind of unknown. It was kind of, no one's farming out here. It's not near the road. It's not near cities. And even today, it takes a good number of hours on kind of a nasty, typical Iceland highland type of road to get into this thing. And I think what we'll see in learning about this volcano is everything we know about the Reykjanes Peninsula and this type of eruption that we're seeing now. We need to almost toss all that information out the window when we're looking at this volcano. So what I decided to do is I'm only working a few steps ahead of you. So I've digested some information about this volcano, read up on it, and I have a little bit to present to you today. So let's call this Askja 101, Lecture 1, if you will, or Presentation Number 1. And in the future, I'll try to add to that as I learn a little bit more about it, reading papers and such. I'll add to my knowledge base and I'll share that with you, if that sounds like a good plan. So you're not going to hear it in this little session anything about the most recent uplift and some of the data most recently. I'll get to that probably later, but I thought we would just do a step back and focus a little bit on some of the background and such with this type of volcano. And again, I'm learning here along with you guys. So hopefully that makes sense and that will work for you. So here's what it looks like. It is, and maybe we should let's start with the Google Earth view, sorry, and then we'll go to the little slideshow. So you can see the obvious lake here, but the volcano is actually bigger than that. And sort of there's this bigger, I guess we'd call it like a massif, like a big topographically high area that defines the volcano. Turn on lights. There we go. More broadly. Additionally, in reading about it, it's an interesting volcano because it also has there's fissures and other vents that have opened up tens of kilometers away from this volcano that apparently are related to it. So it seems to have a pretty extensive and large plumbing system in the subsurface. But we can see sort of this built up ground here. And then, of course, the sort of centerpiece here is this lake that sits in this depression near the top of this mound of material here. We can also see is there some lava flows that are associated with it. So you can see this nice lava flow that spilled out at some point and flowed out towards the east on the north side. There is also a fun little mini lake, Lake Viti, that sits at the north end of the Askja lake, or the caldera, I suppose, with this very different colored water. So you can see this contrasting water here. This apparently is, we can spend more time on this later too, but this is a very geothermal area. So this is warm or hot water, and it's carrying, remember when we have water that's heated, it's able to carry more mineral material in suspension, dissolved basically. So a good example would be, if you wanted a really hot cup of coffee, but you like sugar in your coffee, you can put more sugar into very hot coffee and dissolve it than if you have a less hot cup of coffee. If it's, room temperature or maybe a little bit more than that, you can only stir in and dissolve so much sugar. So the fact that the water in this little crater here, and this is what we call a phreatic crater. It was a steam eruption, so it was groundwater or maybe surface water and magma mixing that kind of blew out this thing, but it was mainly steam driven. But the color here is just the suspended mineral material, mostly silica rich material there. We'll get to that. I'm getting ahead of myself. So here's the where the location is, and again you can see just how remote it is with comparison to the ring road, any of the settlements out here. It lies just to the south of the glacier, and we don't have to go too far back in time. You can see this sort of dirty glacial tongue here. You probably only have to go back a few hundreds of years, maybe a few thousands at the most, when this glacial tongue of this glacier extended out over this thing. So much of this much of this volcano's history of eruptions over the past, tens of thousands of years has likely been subglacial. So most of its eruptive history has been subglacial. So, but that's where it is. That's where it sits. I've never been there. I'd like to get over to this part of Iceland at some point. I guess I need to not. I keep going in May, and you just can't get there in May. There's still too much snow on the ground. It's a little tricky to get there. So I need to make a trip out there in July or August and try to get into some of these other places I haven't been. Okay, so now let's start the little fun dog and pony show here. So nice picture here. So you can see that it sits in this depression. So we'll see that Askja is actually at least 3 nested calderas, but this is a different caldera than you might be used to. And here's that very pretty blue-green, hot silica-rich water over here at this side of the crater. So okay, pretty picture, and then let's move on. So Askja sits along the plate boundary. So here's our plate boundary coming up through the Atlantic Ocean, coming ashore on the Reykjanes Peninsula. So we have an erupting volcano right now that's down here. And then we have there's sort of like 2 branches to the plate boundary. Maybe at some future video I can explain why there's this branching behavior. I don't want to get into it right now. It's too long-winded of an explanation, but it's an interesting story. But there's this west volcanic zone, this east volcanic zone, and then a north volcanic zone. And so Askja sits here. It's part of the north volcanic zone, which includes Krafla and other vents and volcanoes, and then it goes offshore. The extension, the plates are moving apart at about 2 centimeters per year, and I've aligned my arrows to show you the direction of plate motion or extension in that area. And again, this is a very different volcano. Down here on the Reykjanes, we have well-behaved, low viscosity, fluid, fissure eruptions mainly, that are erupting fairly fluid lava, building up cute spatter cones. This is the area where we have very tourist-friendly eruptions. This volcano erupts very diverse material. It's not all the same chemistry. Sometimes it's explosive, sometimes it's not. So it's both effusive and more violently erupted. The scale of eruptions varies from small to huge. And it's often classified as one of the big 4. So the 4 volcanoes in Iceland that potentially could be problematic, not just for Iceland, but potentially Europe. And if we really want to extrapolate a little bit globally, would be these 4. So Askja, Katla, Grímsvötn, and Bardarbunga. Those 4 volcanoes, based on their track records, are the most likely to produce the most widespread impacts. Thankfully, the one thing we always learn in geology and in any natural process is the bigger the event, the less likely it occurs. So we might see, dozens of tourist-friendly lava eruptions on the Reykjanes before we see even one of these big explosive events at one of these bigger volcanoes. So nice little map here that shows you kind of how these lay out. Hopefully this is helpful with some of the diagrams. Here is a more detailed geologic map, and I've got some of the references here. I've been diving into specifically 3 papers, and our good friend Professor Thordarson is a co-author on all of these. So I'm interested if I can circle back to him and maybe do another little question answer interview or discussion on this specific volcano. I think that would be really valuable. But first, I'd like to learn a little bit more. I don't want to go into it with just knowing a few of the basics. I want to digest as much as I can and then have an insightful conversation with him. But what you can see here is the lake shown in blue, and the lake is pronounced, and I'll probably butcher it even though I practiced with the Manja Joe earlier today, Uskevant, something like that. So that's the name of the lake. And that forms one caldera. So you can see one of these depressions here. And just to back up a little bit, a caldera is a type of volcano that can form with collapse. So rather than a crater forming where stuff is thrown out, like our spatter cone right now is throwing out chunks of lava. And in the center of that spatter cone, we have a crater, a depression at the summit. Calderas form differently. They form by collapse. Sometimes it's wholesale, like piston collapse, like the whole floor of the volcano drops down. Other times it can be more blocky and chaotic, and that appears to be what's happened here. So you can see there's 3 clearly defined caldera rims. I believe this one's the oldest one here, this Kotler one. And then there's the Askja caldera, which you can kind of see rimming around this way. And then this youngest one right here. Everything shown in green on this is, if you look at the legend over here, is basically our subglacial material. So all this material that erupted while this volcano was still sitting beneath ice. And so I'll go back to the Google Earth image here in a second, but that kind of rubbly, mounded topography is all from these types of eruptions. It's cut by a series of, you can see the black lines here, little faults and maybe cracks and fissures, but all of that erupted from about 7,000 years to 300,000 years. On this little diagram, Ka stands for kilo annum, or in other words, thousands of years ago. So the green shows you how extensive this volcano has been when it was erupting beneath the ice. And then as we go into some of these other colors here, like this yellow color would be eruptions of lava post-glacial, so after the glaciers had retreated out of this area from 1 to 7,000 years ago. Then in the brown, kind of on the floor of the caldera and then spilling over the rim in places, is stuff that's less than 1,000 years old. And then in pink is material that erupted after 1875. And 1875 is a line in the sand. It's the biggest, it's the largest and most recent of its big eruptions, historic eruptions. And yet we don't know much about it because no one was there. We didn't have any instruments there. Not a lot of people were living in this part of Iceland in 1875. And so our accounts and our data for that eruption, even though it wasn't that long ago, is not as detailed as it could be. So a little geologic map there to give you some context. Light went out again every 8 minutes or so. And then I grabbed this from the Global Volcanism program that the Smithsonian runs, and this was a nice timeline of previous eruptions. So, and we do have eruption histories that go back prior to this 8910 BCE eruption. I think I read somewhere that we know it's been erupting for at least, I think, around 100,000 and maybe as much as 200,000 years. So this is a well-established, long-lived volcano in Iceland. And you can see the dates of the eruption here on the left. These eruptions were confirmed possibly either by eyewitnesses or by deposits dating of the actual volcanic material that was erupted. And then over here on the right, we haven't talked about this a lot on any of my broadcasts, and we'll have to do that at some point. But the VEI is what's called the Volcano Explosivity Index. It's basically a measure of how much material is erupted from a volcano, and it takes into account the volume of the material, the height of the eruption plume, and the duration of the eruption. So those 3 factors dictate how big the eruption is. So it's a way for us to rank and compare various either historic or even prehistoric eruptions. It starts at zero so essentially the little eruption we have going on north of Grindavik right now would be a VEI 0, even though it's been going on for 2 weeks. And even though the town is evacuated, there hasn't been a lot of lava that's been erupted from those vents, even though it seems like a lot maybe to us. So that would be quite small. And then as you ramp up bigger, it's sort of an exponential thing where everything goes up by a factor of 10. But you can see how big that 1875 eruption was. It was a VEI 5. And that makes it comparable to Mount St. Helens in 1980 was about that size. Vesuvius in 79 AD, which killed a lot of people in Pompeii, and Herculaneum was about that size as well. And you can see the duration of that eruption. It started right around January 1st and went to October 17th. Remember too that the data on this is not awesome because, it was over 150-ish years ago or whatever that is. But it was also in a very remote part of Iceland. So there's its eruption history, and its most recent eruption was in the 60s, where it erupted for a couple of days. But since then, we've actually there are some GPS stations there. There are, I believe, some seismometers there now. So we do have some monitoring data in the area, which is really good. Okay, so this 1875 eruption, there was a lot to digest here, but here are what I think are the highlights. So very remote, not a lot of information there. Like I said, this was a weird eruption. Most of our Icelandic volcanoes erupt basalt, the black rock that you see when that lava cools. That's basalt. It's often low silica. It's usually low viscosity. Basaltic volcanoes typically aren't very hazardous unless they're interacting with water. But in this instance, and I probably won't dive into all the mechanisms that we think went on there, it actually erupted a type of magma at the other end of the spectrum and a rock called rhyolite. So this would be a high silica type of magma, one that is explosive because it tends to be stickier and pastier, so it traps gases. And so when it eventually erupts, it erupts quite explosively, and all that ash gets shredded, all that lava gets shredded into tiny particles we call ash. So even though the magma supply coming up was basaltic, apparently there was some stale old lava that had been sitting in the shallow crust for some number of years, a long time, and it had partially crystallized and had turned into this silica-rich type material. And so when that basaltic magma came up, it kind of heated up that evolved magma, and so it became much more rhyolitic. I probably butchered a good explanation of it there, but I'll try to do a better deep dive in the future. The eruption formed that pit where that lake sits today, so that big blue lake and the little tiny sort of Caribbean blue one, all formed at that time in this 1875 eruption. Like we said, it was a VEI 5, so it sent a column of ash up to 30 kilometers into the atmosphere. And some of that ash then was carried, most of that ash was carried by the westerly winds. So this map here on the lower left shows you, this is what we call an isopack map. So it's showing you the thickness of ash and where it was deposited. So all the red are data points where they were able to measure the thickness of ash in the ground, in the soil from this eruption. So you could see it was upwards of, this is I think in centimeters, so 50 centimeters thick right around the eruption site, and then it tapers down as you go away. But some of that ash was even carried into Scandinavia and parts of Northern Europe, where it deposited up to a millimeter or so or less of ash. You can see all the little green data points here that allowed them to build this map showing the distribution of ash over this region during that or immediately following that eruption. So tremendously impactful, right? If you duplicated something like that today in terms of, think about the 2010 eruption and the disruption of air traffic, this would be something on that scale. And actually, this is a bigger eruption than the 2010 eruption in Iceland. So And then my last slide here. So again, we're just trying to digest a little dose of this type of volcano. So this is from Professor Thordarson and his co-author's paper in 2013. But they actually tested two different hypotheses for how this volcano is fed. One one hypothesis was that it has a magma chamber underneath it, but then it feeds that magma out into fissures out on the flank, kind of like Hawaii does today, right? We have the main magma chamber underneath Kilauea's summit, but then there's a pathway or a plumbing system that can carry that off to the east into the East Rift Zone. And what they preferred, based on their data and analysis, was that instead what's happening is the actual magma body, the reservoir that's bringing the magma up towards the surface, instead of coming up beneath the big volcano, Askja, it's actually a broader, wider zone. And so it's feeding simultaneously the big volcano of Askja here, excuse me, but it's also feeding some of these fissure eruptions and vents that have opened up a good, you can see the scale here, a good 20, 30 or so kilometers away from Askja. And so that's pretty interesting that it actually potentially has a deep magma reservoir that's this broad. And, the idea here is that this deeper supply of magma is just as close to the surface here with these fissure eruptions as it is here feeding this central volcano that it has in this area. So pretty interesting stuff. So that's sort of it for what I have for you right now. There's 3 papers I've been looking at so far, but I will probably try to find some more on this volcano and try to learn a little bit more about it. I kind of like the idea of maybe seeing if we can get some more time with Professor Thordarson and see if we can ask him some questions as well about this volcano. Because according to Manda Joe, there's a lot, he's in the news frequently about this volcano. So I think this is, when he's researched extensively, and this would be a big deal if this were to erupt. Thankfully, the bigger volcanoes, again, like I've said before, erupt less frequently. So we don't need to be in a panic right now, but it is an area of concern. And this thing could show inflation for decades before it even culminates in any sort of eruption. And the next eruption could be, something pretty small, like this little eruption of lava here along the flank. But this one also has the potential to be quite explosive, to impact a larger region well beyond Iceland. And so that's why it warrants continuing to monitor and look at. So, okay, so I think I covered all the good stuff I wanted to there. That was about an hour's worth of content. Hopefully that was good for you. Now I'm looking over at the live chat to kind of see what's going on. And if someone can send me the first batch of questions, I don't know if Susan's handling that today or Amanda Joe, but that would be great. I can see there's a lot of questions in there. And hopefully the last hour of me yapping landed well. Hopefully you learned a couple things here. Aston says, fun fact, Viti, so the little tiny lake next to the bigger one here, in Icelandic it means hell, which I guess is fairly appropriate. I guess the water here is, people have swam in it, but it feels like a little bit of a spicy location to go swimming while the water is warm. It's over a really active geothermal system. It's also sitting in this pit crater. You can see there's places where rockfall has collapsed and built these little deltas out along the margin. So yeah, maybe if you're down there, it could feel a little bit like hell. Don't know. Okay, let me grab the first batch of questions from Amanda Joe. Oh boy, she sent me all 3. Okay, so we're going to have to be aggressive here. I will do my best to get through as many as I can here, team. And thanks to our moderators for aggregating all these and putting these together. So let's just throw these up and I'll do my best. Okay, from Janet Clancy, do the deep earthquakes, very deep earthquakes, 10 to 12 kilometers down, have any significance? They've only happened the last 24 hours. Helpful note, did a quick check and all the quakes in the last 24 hours are to the east of the magma tunnel, mostly on the Fagradalsfjord line, though they are marked Svartsengi on the altar area on Vafri. Okay, so I think what Janet's asking about here is these deeper earthquakes over here, because these are the deep ones. So there's one that's like 10 kilometers down. Oh, and probably in this area here. Sorry, I think I'm too far east. But there's one there. That one's 11 kilometers. There's another one in there that's about same thing. Small magnitude, right? 0.6. These are tiny, tiny quakes. And so her question again is no. So the answer, Janet, is no. I don't think they have any significance right now. You know, the magma may be coming up from depth. That may be causing just small, I mean, a 0.6 earthquake is small. So you're just causing small breakage of rock potentially. We would need to see, if these deep earthquakes are going to be significant, we would need to see them either in a new location, but more importantly, we need to see them in high concentrations, big clustering of quakes. The earthquake data we just looked at there just didn't look like, there's just a couple. So yeah, not concerned about those yet. And they don't have to be magmatic in nature. Those quakes might be tectonic. Remember, we're on an active plate boundary. There's stresses acting on the rock beyond magma moving through the rock. And so those may be generating the earthquakes just as much as any magma might. Wessex Dragon, I've been wondering for which rocks hold the most gases within them and how much it affects magmas that's passing through rock types. Trying to understand the question. I'm assuming you mean volcanic gases in volcanic rocks as it's passing through rock types. So with magma, the gases are going to be dissolved in the magma. So the gases are moving with the magma through the system. When it gets to the surface and erupts as lava, the gases are lower in density, so they escape the lava for the most part and rise up into the atmosphere. Some of those gas bubbles get trapped in the lava as it cools and crystallizes, and that forms the cute little bubbles you see in some rock types. In terms of rock types, I mean, if we compare basalt to rhyolite, which are two different ends of the volcanic rock spectrum, it's easier for the gases to move through the basaltic rock because when it was lava, it was lower viscosity, it was more fluid, and the gases could escape more easily. The gases tend to get built up and trapped more easily in the rhyolitic type of magmas, and those ultimately result in much more explosive eruptions. So hopefully that helped a little bit there. Hans Heinrich Olsen, I noticed sulfur gases being alerted. From what depth do the gases get mixed with the magma, or is it along? Yeah, so the gases, the way I understand it, the gases form with the magma at depth. So it's all together. That magma at depth contains potentially melted rock. Well, it's melted rock, possibly little tiny baby crystals if it has a solid component to it, depending on its temperature, and dissolved gases. And those gases will come out of solution as the gases get closer to the surface and there's less pressure on them. Good question. From Ebo63, every time there's an eruption, the GPS data shows the land levels reducing, but always to a higher level than they began. Will the ground ever reduce back to its original levels again? That's a good question. So, yeah, and this only goes back to, I wish we had these plots going back further to, back to pre-November, I guess, right? But yeah, the thought there is correct in that we see, let's use a different one here. Let's use this one. The deflation doesn't always go back to the original point here, right? Like we can see the amount of downward movement since this March 16th eruption is still not as low as it is here. I think that's mainly due, I'm just thinking on the fly here. I think it's because the rocks are hotter and so they're more buoyant. And so I don't think it's necessarily the magma pushing everything up, although that's a big player. But as the magma's moved into the system and had more time in contact with the rock, it's heated up more of the rock. And so it becomes progressively more thermally buoyant over time. So that would be my best guess. So will the ground ever reduce back to its original levels again? I don't know. Like it's gonna take decades or longer even if the eruption stops right now, for those rocks in the subsurface to cool off to the point they were previously. And even then, they were still already hot to begin with. I mean, we've had a power plant and a Blue Lagoon hot spring area there for who knows how long. And so I don't think they would go back to those levels anytime soon. From Ali Hujo, do you think that there would be more volcano eruptions because every month there is one, like in December, then January, then February, then March, so now April, there was a swarm of earthquakes? No, I don't. I think the pattern we established for the first 4 months of this thing, I think now that we're in a very different phase, a very different eruptive behavior, I think all bets are off. So the March eruption has now spilled into April. I don't know if there'll be more eruptions, if that's what you're asking, in terms of more frequency. I think it's all just wait and see. We just need to see. You can't take, these volcanoes are so dynamic and there's so many factors. We can take past behaviors as a data point of just a trend of what we might see, but that doesn't mean that's what we will see. And so hard to say what this will look like moving forward. I wouldn't be surprised if the current eruption lasted until May when I get there, and maybe I could go see it. That would be great. I also wouldn't be surprised if this thing dies down and doesn't do much for a couple months, or starts building back up again for another eruption a few months from now. Like, I feel like any one of those situations is possible. From Martin Volcano, the last official figure I saw for magma influx into the Svartsengi chamber in early March on the Met Office was estimated at 4 meters per second. Do you think, given no uplift, lava output is now around that level? Probably. I mean, I'm sure someone's quantified. I would think now with these two spatter cones going off, there could be some pretty good estimates of output. Yeah, so if the I think the output, I think it's easier to measure with more precision the output of lava, that flow rate, versus trying to model the magma influx rate in the subsurface using different tools. But yeah, I think it's probably in the ballpark for sure. From Keith Dowsett, hey there. How will the lava sample analysis be used to determine whether it was from the dike, sills, below Sunukur, the chamber under Svartsengi, or almost direct from deeper magma source? I think what they'll look at there is to see, I think this eruption's geochemistry will be very interesting to compare to the other twos, because we know the other previous eruptions had magma that came up into the reservoir, chamber, sill, whatever you want to call it, underneath Svartsengi, stayed there for a few weeks or months or whatever, and then erupted. And it'll be interesting to see what that chemistry and what those crystals look like compared to now in early April, when we think the magma is coming directly up to the surface unimpeded. Will we see a difference in not necessarily the chemistry, but you can tell by looking at some of the crystals and zoning of those crystals. You can usually, there's a fingerprint that's left behind looking at those crystals, if they've been sitting in some shallow chamber for some period of time before erupting versus coming through the system directly. So I think the analysis should show that, or should give us some data in that regard. From JCell 657, do you think this eruption is coming from a deeper source than the last few short eruptions? Well, what I think is happening is the other eruptions were coming out of the storage zone, right? So all the magma's coming up from deep, going into the storage zone under the power plant, and the last few eruptions in December, January, and February were trying to work that magma, find its pathway out to the surface. Now I think we have something, and I do need to make a sketch. I have like an image in my mind of what this might look like, and so I need to find time to draw this out with my lousy art skills and see if that will be helpful. But now I think what we have happening is the magma's coming from a deeper source and is either bypassing the storage zone or moving straight through the storage zone, right? So it's kind of like, I don't know what's a good analogy. Like, I'm driving to the airport to pick up a buddy, but I'm going straight to the terminal and he's getting in the car, versus I'm driving to go pick up my buddy, but I have to stop at the little parking lot and wait for the cell phone call to go pick him up, right? There's a transient there's a place where that that the there's a place where I stop and don't progress any further, and then I resume to my destination versus going straight through. So I think that's what's happening right now. So that was question sheet number 1. Let's go to number 2. I think we'll just do these 3, Amanda, Joe. So I think this will be enough for today. So let's go ahead and get this one a little bigger. That might be too big. Whoa. There we go. Gail wants to know, since this eruption is ongoing, do you think there's a constant influx of magma that can supply the vents for several months? Yeah, kind of like we were talking about. Potentially, we don't know. I mean, we're looking at something that's, 10, 15 kilometers down. We don't know exactly what dynamic is feeding that. Is it hotspot magma that's coming in from the hotspot, or is it decompression melting from the plates separating? So we don't even know for sure. And Professor Thordarson and I talked a little bit about this in my conversation with him. It seems to be possibly a combination of both, but we don't know like what percentage. For right now, I guess we would assume, since magma's been moving into this system since late 2020, so we're going on 3.5+ years, that the assumption would be that it's going to continue. And if it's going to continue and it's already established this pathway, I think it could supply magma through the vents for several months. Will it? That's another thing. Wolfgang Grieb, in an interview with Professor Thordarson, Val Trolls, he said the chemical footprint of Grindavik's lava was only seen before in Askja on Iceland. Does that mean it's the same source in depth? I didn't see that, so I'd have to look at that and look at the context of that. Same chemical footprint of Grindavik's lava was only seen before in Askja. What it could be is, I don't think they could be referring to source, but they also could be referring to like the speed of ascent, how quickly that magma made its way to the surface. So I'd have to watch that and see. Sorry, I can't answer that better. Kava, do you think it's possible there would be sinkholes in Grindavik later? The land will fall under houses because of cracks, etc. Don't know how to make this question short. Well, you did. That was a short question. I don't think we're going to get sinkholes. For a sinkhole to form, you need a broad area, roughly circular, but it doesn't have to be, that is a void in the subsurface. What we have in Grindavik, of course, are fractures that have opened up, cracks. We're not going to get any further subsidence in Grindavik unless we have a totally different type of magma movement through the subsurface, or we start getting a bunch of earthquakes in some other area. And since we already had that whole magma dike form through Grindavik up to the northeast, I don't know. So it's possible there could still be subsidence or land falling, if you want to call it that, due to the cracks, but less likely. I think the lion's share of the damage in Grindavik's probably been done in terms of cracks and that sort of thing. I think now the big worry is keeping the lava out of town, but could we get more fractures and cracks opening up in town? Potentially, depending on how this kind of goes. From Freefall, do you have any thoughts or insights on the helium discoveries in northern Minnesota? I don't know anything about that, so I have no thoughts nor insights. It sounds interesting, so I don't have more there. Easton wants to know, can you talk about SciShow and how you came to be a guest there? Yeah, they just reached out to me with an email, and I mean, I guess I could try to find it real quick, but it's right here. They asked me, someone named Amy just said, I'm an editor for the YouTube channel SciShow. We delve into all manner of science stories and explore the unexpected. I'm in the process of working on a video about some of the ways that researchers monitor volcanoes, and in particular, how some methods of predicting volcanoes, like remote sensing of gases, only work in the daylight. To that end, we were thinking it would be especially exciting for our viewers if we include an on-screen interview with you as an expert in the field. I chuckled when I saw that because I do not consider myself an expert in the field. We're not in a position to offer compensation for this interview, but we would, of course, credit you and link to your YouTube page in our video. If this is something you're interested in, please let me know and we can find a time for the interview and discuss the details. And so I reached back out to them and said, I'd love to do it. I also let them know, I just even said right here in my email back, I said, I am not a professional research volcanologist. I don't know if that matters. But I am happy to chat for the interview, and I pride myself on trying to use good communication skills to convey science to the layperson. So they apparently were happy with that, and so that was back in January when they contacted me. I think we did the interview in February. Yeah, February, and then it just came out. So yeah, I didn't even know about that channel, and now I've looked at some of their stuff, and they do really great work. So I'm glad I got to be on there. It was great. From Jocelyn Meadows, I am 87 years old. That is awesome. And I've always loved geology. I studied many years ago. I'm hungry for knowledge about our planet. I love your presentations. Thank you. Well, thank you, Jocelyn. That just made my day. I love that you are eager to learn. I love that you're passionate about this like I am. And this is the kind of thing I live for. This is the kind of thing that stokes my fires, hearing comments like that where you found my channel and maybe you found some others. You found good outlets to learn more geology. And I think that might be why you've been able to make it to 87, is you're just keeping your brain active with your quest and zest for knowledge. So kudos to you, Jocelyn. Thanks for sending that comment. Aston, he's got a second question in here. Can you explain the difference between geologist, geophysicist, volcanologist, and other similar titles? Sure. Well, yeah, sure. And then I think about it and I'm like, oh, this is trickier. And then there's all other types, right? Like I could make a laundry list, of 30 different types of geologists. So as a student, when you decide, in college or university, you're interested in geology. For me anyway, that led to a bachelor's degree in geology. So at that point, I had taken classes in all sorts of different types of geology, from sedimentary geology, all your basic rock types. I'd had classes in, and you get to pick and choose a little bit too. So there's electives, right? Like some people might take some water classes. I took some geochemistry classes. I have a minor in chemistry. I did not take a geophysics class, even though I had to take physics classes. And what else did I do? Sedimentology, stratigraphy. So there's all these different geologists there. So a geologist would just be a person who studies the processes and materials that make up the earth. So earth, what the earth is made of, how it works. That would be the most broadest type, right? So all of these people are geologists, but if you're a geophysicist, you have knowledge about geology, but you probably have some more advanced knowledge about physics. And so a lot of geophysicists are using physics as tools, advanced tools, to understand geologic processes. So geophysicists might be involved in looking at the patterns of earthquake waves, and they might really specialize in earthquakes and become a seismologist. A geophysicist would be helpful to have in locations like Iceland or in Hawaii, where we have volcanoes erupting, because they can use measurements like changes in the gravitational field, electrical currents, maybe the ground deformation that we've talked about before. A geophysicist would be very helpful at looking at the physics and physical behaviors that help us with maybe a volcano. What else would it do? Oh, geophysicists in the oil and gas industry could be helpful because you can run electrical currents through well logs or boreholes and analyze those and interpret them. A volcanologist obviously studies volcanoes, so they're going to be primarily looking at the way magma behaves in the subsurface, how it erupts, eruptive behaviors, magma compositions, the role of gases. So we had our interview with Dr. Ariana Soldati, and she's a volcanologist. So she and I are the same in that we both have bachelor's degrees in geology. But then as we have our advanced degrees, she's specialized more in volcanology and learning a lot about volcanoes and behavior. My degree program was a little bit of volcanology, but mainly structural geology, looking at faults and folds and the way rocks deform and break. That was the path I took, and the volcanology stuff I've learned has kind of been on my own on the side. I did take one or two volcanic or volcanology classes in grad school. But yeah, hydrology would be water, looking at water and how it behaves. Geomorphology would be looking at landforms and how like landslides behave, or the surface that's formed by water moving, like in a flood, like a river and streams, how that can deposit sediment and erode. Yeah, so hopefully that helps a little bit, Aston. There's all sorts of, there's paleontology that looks at fossils and ancient life. There's all sorts of subsets of geology that are out there. So I could go on and on, but that's hopefully a little snippet there. Carl Fürstenberg, is the liquid lava level constant, or will it rise when the spatter cone gets higher? So turning the light on again. I think you're talking about is the spatter cones are erupting. The liquid lava level, well, there's a couple things happening. So the position of the spatter cone can change a little bit, right? As that lava's coming up, it can thermally erode and cause it to sink a little bit. At the same time, you're throwing that lava spatter out onto the flanks, and that could cause it to build up. So as the spatter cone gets higher, I mean, right now, the last couple of days, we've been seeing fairly constant levels of activity. But the liquid lava level, it depends a little bit on how much is being thermally eroded around the vent. So hard question to answer because there's a couple of variables there that we don't know for sure. All right, Jess Stromify, is the magma now, if the magma now is fed directly from the lower source, is it compositionally different? It might be. So that's why we want to get a sample of this March to April eruptive material and see if it is bypassing the storage zone. I think chemistry-wise, it's probably the same, but we can look at those crystals and where they've started to cool, like they come up, to 5 kilometers depth and they start to cool a little bit more slowly there. And so we can see those differences to see if it's coming straight through the system or if it's spending some, residence time in some shallower body. JMS, have you seen the GPS site with the vectors plotted? Brilliant, really shows the rifting. I think so. I've seen a couple things like that with the GPS sites with the vectors. It shows, it does nicely show which direction everything's extending. I'll try to show one of those in one of the upcoming videos or something. Okay, and now he looks for the last set of questions from Amanda Joe. Hopefully folks are still hanging with me here. We'll wrap this up quickly. Hope you're enjoying this. Hope you're treating our moderators well. Thanks for folks who've been able to support the channel and the good work we do here. All right, Gail, what event would stop the influx of magma into the chamber that is erupting? The magma tends to come up, we think, based on just modeling and subsurface data. We think it kind of comes up in sort of like blobs. Like it's not like it's like a chimney per se, but it comes up as just these masses of magma that rise towards the surface. They can stop for a period of time in the crust or lower, depending on their buoyancy. And then as maybe more magma comes into them and more gases, that might allow them to rise even higher. So basically the influx of magma from depth, that's a subsurface process that we don't have a whole lot of information on. Yeah, tricky one. Aquamoy, where do the volcanic gases come from? They're just dissolved. I mean, you'd have to go back to we'd have to talk about origins of magma, which can take place at subduction zones where one plate dives beneath another, hotspot settings like Hawaii and Iceland to some degree, and then divergent boundaries. Those are 3 different types of settings that we generate magma, and the volcanic gases are just sort of included there. So I probably don't have a lot of good insights there. I know that probably wasn't very satisfying. They're just dissolved and mixed in with the magma at depth. Eric V.D. Luft, what do you predict for the westward breakouts to the north of Hagafeld? Yeah, I don't. Right now, I'm not too concerned. So this person is um, mentioning these. We have had a few little breakouts here. I don't think this map that the Met Office put out is not as crisp as it should be. I think you'd have to really pile up. I don't know what the contour lines on this are, these meters, if these are 10 meters or 5 meters. It would take a lot more lava piling up around the vent here in order to get stuff flowing this direction. And even if it goes, we have one defensive berm right here. So we do have protection there. Probably the more likely scenario is this southern lobe where it filled in the quarry. This could go further, and it probably wouldn't even go straight west. It'd probably start turning a little bit to the southwest, and it would be riding alongside the January 15th lava flow here. So that's the more likely scenario that we might see something like that. I hope that's what you were asking there. Yeah, I'm not making a prediction if we continue to get lava pouring out of this thing for weeks and months, though. It's got to go somewhere. And so we will see more breakouts. We will see more lava going into new areas. Then it's not going to all just keep piling up on top of where it is now. From Giles, in my humble opinion, the eruption is slowing down because of the pressure of the mass of land slowly closing the plumbing system as pressure of magma slowing down instead of less magma from reservoir. Ideas. Okay. I know you guys are limited on your questions with the live chat, and then I just have to kind of piece it together. It's slowing down because of pressure of the mass of land slowly. Okay, so I think what this person's saying is that as we're erupting lava onto the surface, we're adding dense, heavy rock onto the surface. That's pushing down on the land, and that could be impinging upon the conduits and the plumbing system that the magma is using. I don't think that's the case. I think the plumbing systems are deep, and the pressure that the land is exerting is probably not influencing the pathways and the conduits that are in the subsurface. The rock is quite dense. I just can't imagine you're impinging and squeezing down a conduit that's maybe 4 or 5 kilometers down. So that's my take on it. Matt Bax 31, does the nearby topography channel the volcanic gases in a particular direction? Do the hills between the eruption and the Svartsengi offer any sort of protection? That's a great question, Matt. I don't think it matters. I think the wind is the big thing. So all things being equal, if it was, and maybe someone in Iceland can let me know if this ever happens, but if we had a completely calm, still day or morning on the Reykjanes with no air movement whatsoever, I mean, you're right near the ocean, so I think this is very unlikely. But if it was completely still, then those volcanic gases, which are quite dense and heavy, would flow down topographically, probably to the south, and probably would spill over these penetrations in that area. Oh, did we get unconnected? Okay, looks like we're okay. Is everything good? I got a little notice from OBS that we were disconnected but then connected. So can someone let me know before I finish that thought if we're good to go? Anyone? Can you hear me? Because it looks like it's recording. Oh, we're here. Okay, thanks, Brian. Okay, yeah, so if it was completely calm and still, those gases would go into these low areas. But because the air is always moving in Iceland, it's always breezy to some degree, then that's the dominant force that's carrying the winds. So, yeah, good question. Aussie Yarny, how did you become passionate about volcanoes? I thought it was only a small group of people. I think a lot of people are into volcanoes. I think in college, as I was finishing up my bachelor's degree, I was applying to graduate school, and I had to decide if I was going to do volcanology or something else. I went to Oregon State and the University of Oregon in, I think it was spring break of 90. I don't know what year it was. It was my junior year. I had one more year left to finish my bachelor's degree. And I thought I wanted to do volcanoes. So I was always interested in volcanoes. And I went to the schools and met with some of the professors there, and we talked about research projects. I was all set to do it. And then I came back to finish my senior year at Weber State, and I had an amazing professor that taught structural geology, and I became completely captivated by structural geology and how rocks can deform and faulted monoclines, and I was just smitten with the quantitative and also just the processes and dynamics of deforming rocks. And so that last year I switched gears and I decided I didn't want to do volcanology. So I didn't apply to those Oregon schools, and I instead started looking for professors I could work with to go learn more about structural geology. So I found a professor at Northern Arizona University, Paul Umhofer, who passed away a few years ago, and I worked on a project with him down in Baja California. But the love of volcanoes was always there, and even down in Baja, even though I was doing a structural thesis and project, I was looking at volcanic rocks and what we call volcaniclastic rocks. So these are volcanic sediments. They're sedimentary rocks, but they're in a volcanic environment. And so it just kind of was always there. And then once I started teaching and looking for places to take students on field trips, and Hawaii looked like an amazing place to go, and started taking students there, I became more interested in monitoring Kilauea. And then that evolved into going to Iceland for the first time in 2016, 15 with my wife, and then it kind of took off from there. So yeah, so I love volcanoes like a lot of you. So that's why we're here, right? Michelle, wondering if there was info to be gleaned from the deeper quakes occurring prior to this eruption, suggesting deeper plumbing changes while we were all eager anticipating the shallow signals. I don't know for sure, Michelle. Like that would probably be a deeper dive analysis that someone smarter than me would need to do. But I don't think the deeper quakes, because we didn't see a lot of them, they were almost all exclusively in that 4 to 6 kilometer range. I don't think there was enough of them that could be really looked at and you come to any sort of conclusions or really analyze. From Aluin Lark, how does magma regenerate in the earth, or does it not and will run out at some point? No, magma is regenerated. Subduction zones where one plate slides beneath another is one place we generate magma. As one plate's pushed down deeper into the earth, it drives water out of that slab that's been at the bottom of the ocean, and as that water is injected into these deeper parts of the mantle, that lowers the melting temperature and allows it to melt. So if you do the right things to this layer in the earth called the asthenosphere, you can generate magmas. You can either do that by reducing the force or weight on it or pressure on it. That's what happens at a divergent boundary like Iceland. Yep, so it regenerates in a couple different settings, and it's not going to run out anytime soon. As long as plate tectonics continues, we will have magma, and therefore we will have volcanoes. Mantelwen, on the past Met Office reports the inflation was reset to 0 on the graph after events, but the GPS didn't go down to the same level. Should they reset to 0 really, or was that for public friendliness? I must have missed that. So the inflation was reset to 0 on the graph. I'm not sure which graph you might be referring to there. So I don't have a lot of insight into that. Yeah, not sure. I think you mean they just bumped it all down. I mean, it's somewhat arbitrary, right? Like the 0 on this, it's just a reference point, right? You're referencing the upward or downward movement of the GPS station next to some arbitrary point. And so what we just need to see is the station trending upwards or downwards over time, and how does that look over some length of time. So yeah, I'm not sure. You'd have to ask the Met Office that. Not sure. And then finally, our last question of the session, Christian 2 Comedy Rodos 29. That's quite the handle. Can new magma dikes make a volcanic system bigger than it already is? Sure, if you mean aerial extensively, if you bring more magma if more magma is brought into a volcanic system, brought up along dikes that are maybe widening as magma's brought up. You can make it bigger in terms of like over a bigger area. In terms of taller, maybe not so much, depending on the type of magma that's carrying, but can it make it bigger? Absolutely. And I think, we see that to some degree with this volcano we learned about today. The Askja volcano is much bigger than it would seem to look. I think you look at it and you focus on the lake, and then I might get you to kind of like look at this area here, and you're like, okay, I could see that being the volcano. But this volcanic system apparently extends out to the south several kilometers. And then more extensively, it goes out to the north. And so I think it goes all the way out to, there was some lava flows I was looking at out here that were apparently part of it. I'd have to look and see that again. It might be one of these ones. Anyway, but it's much bigger than just its outward appearance would suggest. It's a much bigger system. So anyway, okay, team, how did we do? We made it pretty far here. I'll look through all the live chat stuff later, but hopefully good things were happening there. So we'll go ahead and wrap this up here. What's next moving forward? My gosh, my April and May is like insane. My Iceland class starts tomorrow. I need to get ready for that. I'll probably put out another update. We'll have to see what happens. Maybe Friday or Saturday. In the meantime, I'll get at least one of those Europe trip videos prepped and out to you guys, so you can check that out. I'm doing a talk on Monday to the Utah Geological Association, so I'll be down there on Monday. I'm hoping that they can record it, and well, they can record it. I'm hoping I'll get a copy of that, and then I'll put that up here as well for you guys to enjoy. And then looking forward, I've got some field trips with classes. I got the YouTube field trip with some great viewers on the 12th and 13th. And then May gets crazy. The semester ends. There's all sorts of grading, graduation. And then I leave on May 13th for about 2 weeks or 2.5 weeks in Iceland. So that'll be a big thing there. And hopefully I'll be able to see some things. Not sure. I have been talking to our good friends at Nature Eye, and they promised me that as soon as they can get a drone up over the area, that I'm the first one that they'll call. And so we'll see if that can happen. I mean, I would love to be able to, have the kind of drone footage that other folks have and combine, their great drone footage with some of my geology commentary. That would be awesome. But they're doing their thing, I'm doing my thing, and that's okay. So you got to kind of splice it together as best you can. So we'll go ahead and sign off here, but I hope you learned some things today. We learned a little bit about this new volcano that we're going to kind of take a peek at every now and then. I think I'll kind of let it lie, but I'll try to put together another little session on the Askja area. I also want to be able to put together some Geology 101 videos. A lot of people have talked about like my Geology 101 lectures, if you will, and I do have some material there. I just need it's just about finding the time. I think once I can get through May, there'll be a lot more time for me to devote to getting some content out to you guys. But in the meantime, look for Iceland updates, look for some new field videos from Prague area, Vienna, and also Central Park, New York. And then then look for those interviews as well. I'll get together with Greg Stock and Gylfi, and we'll get some interviews done. Not sure if those will be video recording interviews or they will be live streams. The live stream thing might be trickier, but we'll see what we can do there and get some information to you guys. So have a great day. If you're up late at night in Europe, thanks for staying up with me. Appreciate your time. Thanks again to our moderators, Susan, Lisa, and Amanda Jo. And one more time, happy anniversary, Amanda Jo. Thanks for spending time with us today, and hope you guys enjoyed the live stream. Take care, be well, and keep learning, team. We'll see you next time.